All right, triglycerides, also known as fats. They're going to consist of a glycerol molecule, glycerol, and three fatty acids. Three fatty acids. We'll talk about them in more detail in a second. And they're going to be joined by, you probably guessed it, dehydration reactions. Dehydration reactions. Okay, so this is going to be our glycerol molecule here. The orange one has 3 carbons and some OHs here. And the thing is that because of this, this is going to be a dehydration reaction. Dehydration reaction. Okay, there's going to be actually 3 of those. And that's how we join them. That's how we join the fatty acid to the glycerol. The fatty acid is going to be pretty much made of hydrocarbons. Hydrocarbons, which are a lot of carbons and hydrogens. So these tails are going to be very hydrophobic. Okay, hydrophobic means they're going to be kind of scared of water, which is why fats, okay, are going to shy away from water. That's why fats don't mix with water, because the tails, which are humongous, are hydrophobic. They don't like water. Main function of fats are going to be one, energy storage for long term. They have way more energy than sugars. Why? Because these guys are going to have a lot of energy because they have a lot of bonds. Lots of bonds. Okay? So they're going to hold on energy that we can't use on a given day. We're going to store it in adipose tissue. Another function of fat is usually for cushioning, okay, vital and sensitive areas like the kidney, and also going to be for insulation, layers of fat to prevent heat loss. Now, this may not be not much for us as humans, but let's say, for example, seals, for example, or whales, they have a lot of these fats because they need to stay warm, right? So that these are fats. Now let's talk about fatty acids themselves. And in terms of fatty acids, okay, we're gonna have 2 types: saturated fatty acids, saturated fatty acids. Saturated fatty acids, the carbon skeleton has the maximum number of hydrogens. So all of the carbons, the carbon-carbon bonds are going to be single bonds. They're going to be linear molecules. There's going to be no bending, okay? Um, and this is going to be the example of saturated fatty acids over here, okay? They're linear, okay? There's a lot of carbon and hydrogen bonds, all right? Carbon to carbon is going to be single bonded. So it's going to be very, so it's really, they're so stuck together. Think of them as stuck together, right? They stick together because they're pretty much lines. Now, the other type of fatty acid are going to be unsaturated fatty acids. These carbon skeletons have a fewer than the maximum number of hydrogens. So they're gonna, and why? Because, well, one of the reasons why is because they're gonna have one or more double bonds. So something like this, carbon-carbon double bond, all right? Which is gonna make some kind of kinks. Okay, so this is what I'm talking about. Look at this. It's a carbon double bond over here. It's a double bond, and that is making like a little kink here. So they're not stuck together. All right, they're kind of, there's space between them. There's gonna be a lot of space between these guys here, for example. Okay. Now, most animal fats are gonna be high in saturated fatty acids. They stack together on each other, which makes them solid at room temperature. Okay, it's probably the more dangerous ones, right? You want to kind of keep it easy on these ones. Plants and fish fats, however, why do they think, oh, what does your doctor say that, hey, you want to eat fats, eat fats from plants or from fish? Because these are going to be high in unsaturated fatty acids, which are going to be liquid at room temperature. Okay. And again, why are they liquid? Because they have unsaturated fatty acids. Unsaturated fatty acids, there's a lot of spaces around here, so they're not be able to stack. So therefore, they're liquid at room temperature.